So when you're doing a confidence interval and you're doing your assumptions, you're trying to decide if the sampling distribution is normal. We've learned two different ways. We've learned when the population is normal and it's given to you. We have learned when your sample size is greater than 30, you can just say, by the central limit theorem, my sampling distribution is normal. If we look at this example right here, we only have 24 data points. You can only use this method when they give you the data. So anytime they give you a list of numbers, that means that you're going to have to put them into a list, and we're going to need to graph it. So the first assumption, I'm just going to write, let's see, there were 24 individuals, a random sample. So there is a random sample of 24 individuals. You can. It just is wanting a random sample. And then the second one that we're wanting to decide is if it's normal or not. The only way that you can prove that your distribution is normal is by graphing. There are two graphs that you can construct. So you can either do, this is just for notes purposes on the side, this isn't a part of the write-up. You can either do a box plot, and you want your box plot to be linear. I'm sorry, that was wrong. So you want your box plot to be symmetrical.
So when they give you data, you have to graph.
If you do a normal probability plot, you want that to be linear. So there's two options, and you can choose whichever one is your favorite. Student choice. These are just little notes out to the side. So what I'm going to do, I'm going to pull my calculator over to the side. So what we want to do now is we have our data graph, or we have our data in list 1. And I'm going to make, let's do a normal probability plot. So second y equals, hit enter, and the probability plot is going to be the very last one. If you have just an 84, not the plus, it's the bottom right hand one. But you have to hit the right button. And you want your data list L1. Really shouldn't change anything else. Then hit zoom. Actually, my plot wasn't on. Make sure that the plot's turned on. It was off. There we go. Now hit zoom, and then zoom stat, which is 9, so zoom 9. And here's my normal probability plot. So what you'll do, something that's really nice about on the AP test, is you will draw this picture and you'll make your dots as good as you can. They just draw the pattern where the only thing that they really care about is the general pattern and then labeling your axes. So your x-axis is going to be the what is my x value? Like, what am I measuring? My context. Is it time, I think? What do the numbers represent?
Hours spent studying.
Yeah, hours. So hours spent studying. And then my y-axis is going to be all of my normal scores or my z-scores. Yeah. It doesn't need to be perfect. Just label your axes. And you don't need any numbers at all.
And what's this thing called again?
A normal probability plot.
Is linear regular to integrals one?
The box plot would be symmetrical, and the normal probability plot you want to be linear. So then underneath the graph, you will say, since the normal probability plot is approximately linear, the sampling distribution is approximately normal. So if you don't want to do that, then you can do a box plot, which for type it's going to be the one with the dots on it because that has the outliers. Zoom 9. And the only thing that the reason why I don't really like doing a box plot as much is because to me that doesn't look super symmetrical. It looks a little bit more right skewed. It's harder to tell. The normal probability plot looks a lot more linear than this looks symmetrical. So I usually just like doing a normal probability plot. But anyway, with that, you would write the x-axis, which is time spent studying, and then hours. Yes, that's what I do, but no. And then underneath the box plot, you would say, since the box plot is approximately linear, the sampling distribution is approximately normal. And you'll also want to put numbers. I didn't label my numbers on the box plot. So to do that, if you hit trace, and then 2.5, 7.5, 9, 14.75, 22. So just putting under the numbers.
Do we need to know how to do that for the AP exam?
How to find the 5-number summary? Yeah.
We need to know
We've done that.
though?
Well, you'll be given questions about box plots independent of this chapter. You'll be given lots of questions about box plots.
How to do that, like this specifically.
Yeah, but you can also do the 5-number summary by doing 1-var stats on a list of data, and it gives you the same thing.
Oh, okay.
Yeah. So you'll want to label your numbers. Say, since the box plot is approximately linear or approximately symmetrical. I know I get them mixed up all the time. Box plot is symmetrical. The sampling distribution is approximately normal. I do normal probability plot, but it's up to you. So once you have the first two assumptions, the last assumption is that sigma is unknown. So far you should have that we did the random sample, we did the graph, I'm just not rewriting it, and then the third assumption is that sigma is unknown. So write that underneath.
The graph is linear, so I put like the normal
The thing that I wrote out at the beginning. So you have the graph, this, and then you write a nice sentence that says, since normal probability plot is linear, sampling distribution is approximately normal. And you have to have both of these. If you don't have the graph and the support of the graph, then you won't get credit for it. Okay, third thing, sigma is unknown. Now we want to do calculations. This is a t interval. So name of the test. It is stat test 8. So if you go to stat test 8 right now, there's a tab that says data. So all you will do is put in data, and then it should automatically come up as list 1 where you have your data. And the formula by itself is x bar plus or minus t star s over square root of n. Then my x bar, I got 10.92 plus or minus. I don't know what my t star is, but if I go to second bars, inverse t of 0.975, and then how many degrees of freedom do I have? 23, because it's n minus 1. I'm going to do that in a minute. And then my s is 5.6 over the square root of 24. Then my interval, I got 8.5527 to 13.281. For my T-star, I got 2.069. So then my last thing would be my conclusion.
Upper scroll, pardon me.
So conclusion. So we are 95% confident.
Have fun, Drew.
The true mean, what was the context? Hours spent studying for, I don't even know. What does it say? Hours spent studying for what? An online course. You wouldn't say the last exam because that's past tense and we're making predictions about the future. Is between, what was it? I lost it.
Hey, what's that? But I get along with that.
I have it. 8.5527 and 13.281 hours.